All right, so now we know fg prime equals f prime g plus fg prime, and we know why that is the case. So what can we do with it? So let's say you had a function like x squared times sine of x. And that's your, let's call this, I don't want to call it f of x because I already have an f of x. Let's call this, I don't know, q of x. All right. So here's the process that you want to get really good at. There are two factors here. We call them f and g. And we're going to write f prime g plus f g prime. And then we're going to say that q prime of x is equal to, all right, f prime is 2x, g is sine x, plus f is x squared, g prime is cosine x. That's it, done. There's nothing we can simplify. I mean, if you wanted, you could factor out an x, but it's not really that helpful. Okay, what if I had p of x equals e to the x times ln x? All right, remember, by the way, because I've only mentioned it, I think, once, that the derivative of ln x is 1 over x. This is something you just want to know. All right, so then identify your f and your g. Here's f, here's g. So we have f prime g plus f g prime. All right, so p prime of x is equal to, so f prime, derivative of e to the x is e to the x, g is ln x, so we just leave that ln x, plus f is e to the x again, g prime is 1 over x. There you go, boom, there's nothing we can simplify. I mean, if you want, factor out the e to the x. I mean, you could do things that you want to do, whatever, plus, right? You can do that if you want, but you don't have to. All right, so that's how you use the product rule. Oh, here's an example that's less obvious. I'm going to call this z of x. Why not? Z of x is sine squared x. Now, we're actually going to have a different way to do sine squared x, probably on Friday. Assuming the schedule doesn't change again. Bug on my paper. All right, so what I can do, though, for now, if I don't know what's called the chain rule, which I'm going to learn next lesson, is what's sine of x, or we'll write the sine squared x as sine of x times sine of x, and then sine is f, and sine is also g, so then I can say what z prime is. Z prime of x is equal to f prime g plus f g prime. So first I'm going to put derivative of sine, which is cosine, times sine, and then plus the f is sine, times the derivative of f, which is cosine. So that you would pretty much want to rewrite as 2 cosine x sine x. Yeah, that's the derivative of sine squared x. There's no other way to get that. I mean, all right, I just told you there's another way to get that, but apart from the product rule or what you're about to learn in the chain rule, let's put it this way. Using what you have learned so far, there is no other way to do it than the product rule. All right, so that's how you do that. Now, oh, by the way, I was going to mention that in my previous video, I said this was section 3.4. It's not, it's 3.3. All right, what if you have a quotient, though? Quotient rule. Okay, I'm going to give you a spoiler alert again. This time I'm just going to tell you it. If I have a quotient and I want the derivative, wouldn't it be nice if it was something nice and simple? But it's not. It's f prime g minus f g prime over g squared. What? All right, so I'm going to show you the proof of this again. It is in your book on page 120. So the proof is on page 120. Again, you don't have to know the proof, but I just want to walk you through it. It's understandable. So once again, and it's also similar to the previous one, so it's nice to see that way. So I want the derivative of u over v. So derivative of u over v, we once again start with the limit definition of the derivative. So it's going to be u of x plus h over v of x plus h minus u of x over v of x. Right? And this is derivative of u over v. All right. So the first thing that they do is they've got this complex fraction, right, or what we call compound fraction. So they take these denominators and they just drop them down here. So that's algebra. Actually, I guess what they're really doing is they're multiplying the top and bottom times v of x plus h times v of x, right? So that way the v of x plus h cancels in this term, but then we have u of x plus h v of x, right? And then the v of x cancels in this term, so then we have u of x, v of x plus h, and then those two both show up in the denominator. So we're basically just multiplying the top and bottom by v of x plus h times v of x. All right, so that's first step. Okay, then they do the magic adding in and adding out thing. So it's derivative with respect to x of u over v, and so I'll show you that. And then here's our limit statement. Here's what they decided to add in and subtract out. So everything up here is here, right? This guy is here. This guy is here. The denominator stayed the same. Denominator stayed the same. And then we just subtracted this thing that's, using something that becomes 0 in the original. All right, so plus and minus, we added and subtracted this time v of x, u of x. And then do some hocus pocus, factoring out. Like, what are we factoring out this time? We're factoring out the v of x. It's pretty similar. Here's the v of x. So we're factoring by grouping again. There's the v of x. And then, so the u of x plus h is here. The u of x is here. Looks like they, in the same step, pushed the h up to the numerator. So that h that was in the numerator, let's see if we can find a color to trace that out. That h that was in the numerator, they just pushed it up here. Algebraically, hopefully you can see how that works. Think about it if it's not obvious. And then what? In this one, they factored out the u of x. So here's u of x and u of x. It looks like they factored out the negative with it. Yeah, they factored out the negative because, right, see how this is positive right here? The v of x is positive, but we really want the v of x to be negative, so you're going to have v of x plus h minus v of x. So they factored this negative sign out here. They really factored out negative u of x. All right, and then everything else is, let's see, so then this term now picks up the minus sign from here, so it's here, and this term is here. And then, once again, you can like distribute the limit out, and when you distribute out the limit, so v of x is just going to stay v of x, right? This is the limit definition of u prime, so that's u prime of x. U of x is going to stay u of x. This is the derivative of v, so it's v prime. Now in the denominator, as h approaches 0, right, this is going to go to v of x, substituting 0 for the h, so we have v of x, but then we have another v of x. So essentially this v squared x in the denominator is a common denominator, would be one way to think of it. Or it's like, I guess it's really the result of multiplying this, which is the common denominator for these two to begin with. Yeah. So this is another way of saying this. Once again, all you have to know is the result, and in the next video we will show how it is applied.